Hi everyone, welcome to Oracle Database Programming, Section 12. This is going to cover data manipulation language. When we talk about DML, that's going to be any sort of command that's going to allow you to change the data in the database, and really that's talking about three different operations. It's inserts, updates, and deletes are generally what we would expect when we talk about DML. I'm skipping section 11, so if you don't see a video for that, that is intentional. So section 12.1 is going to be discussing primarily inserts. Now there is one other way to create a copy of a table, and we're going to use this. Normally we would be able to go in and say something like this and get a list of all players on a roster, or songs or whatever. But let's say we wanted to create a copy for testing purposes, something to maybe mess around with, and maybe it doesn't need to be connected to real systems. We say create table roster copy as, and then you put a query in there. Now, I'm just using take everything, but we could certainly go in and add criteria. We could make more complex queries if we needed to. Certainly possibilities if you wanted to do that as well. But generally, this is going to be a way for us to extract that data and put that somewhere. So we'll talk more about create table in the next couple of sections, but watch at the moment when I give this a run. Instead of seeing the results, we now see table created. I'm going to do something similar for songs as well. And again, you see table created. And what that allows us to do is we now have a copy of this separate from the original. And that means we can test, if we make mistakes, that's fine, which is why when Oracle's going to have you do this stuff, they have you make the copies first. Now let's talk about adding new data. Traditionally, if we're talking about any sort of application, the database, the select is a very important piece. You're looking the information up, you're searching, and that's the queries that we've written so far. But we're going to need to be able to add new data. We're going to need to be able to update existing data, and we'll be able to delete data as well. So I'm going to make this copy of songs as we did earlier, and I'm going to do some adjustments here. So we see SCO5, Stairway to Heaven. This is by band Led Zeppelin. Let me switch this up to a lot of rows for the moment. So what I'm going to start by doing is doing insert into, giving it the name of the table, and then listing off the fields in the order I plan on inserting them. We'll see that you don't always have to do that, but it's a good practice to get into the habit of doing this way. And I'm inserting a new song called Four Sticks. That was also on the same album as Stairway to Heaven, album AB05. I'm giving it a song code of SC95, a song title of Four Sticks, a duration of 285 seconds, a genre of rock. Since this is new, 0 plays, 0 likes, 0 skips, and there's the album code of AB05. And again, as opposed to a select query, instead of getting feedback where we see things, we just see the row is inserted successfully. Now, as promised, there's another way to do this. You do not have to list out the fields. You would just kind of have to know what order things are going to be stored in your system. So this is a shorter way, but there are challenges if somebody renames a field or somebody inserts a field or deletes a field. Your query won't know, and it may insert data into the wrong field. So traditionally, you would put the field list there just for that purpose, just so you get a meaningful error message out. But assuming you're certain it's not going to change, this works as well. And you'll see that even without that, we also get one row inserted. And let's check this. And if we look down bottom, we see both have been successful despite the two different ways to insert them. There are times you don't even have to list all the fields. So if we describe our songs copy table, we see that a lot of these fields are listed as nullable. So what that means is that those values could be null if we wanted to. So for example, genre is nullable. So let's take a look at an example of how we would do that. And what we'd find is if we wanted to insert a null value, we certainly could go in and do this. Now the fact that this is a nullable, that is a decision that you make when you set up the table. That's going to be something we talk about in constraints, which will be, I think it's section 14, where we'll get into constraints and kind of making sure no bad information gets in your table. So if we run this, again, one row inserted, and we see when the levy breaks is in there, and we can see that there is a null or an absence of a value right there for the genre. One more variation. In order for this insert statement to be accepted, we have to insert values where required, and if there were any sort of constraints, which we really don't have any aside from not null, those constraints would have to be satisfied. So you couldn't insert like a negative salary or something, or negative play count if we had those constraints. Really, the only field that's required in this table is song title. But notice if I only say let's insert the song code, the song title, and album code, it's going to be successful, and we just see we'll get a bunch of dashes indicating there's no values. Now, if you don't want this to happen, stay tuned. Section 13 and 14 will get you taken care of. Now, for the last example here for inserts, I'm going to have to use the roster. And if we remember, that had a date of birth for each of the players on the football roster. The dates are not quite as easy sometimes. If we are the ones inserting it, or if we are writing an application in Java or Python, we can format it a certain way so we don't have to do any conversions. But there are times where you have to read data in from plenty of other formats. You might have to read it in from an Excel file, a comma-separated values. Data comes in from a lot of different places. So you may need to force a conversion. So since we last left our rosters, the Giants have acquired a player named Ray McLeod. He's a wide receiver wearing uniform number 88 out of Clemson University, born October 15th, 1996. I list the fields, and then I list the values. First one's going to correspond to the player ID, second to the first name, third to the last name, and so on. This should match up. Now notice I have correctly spelled out the date of birth in the exact format that this is expecting. So this should go through with absolutely no issue. And we see one row inserted, and there's Ray. So likewise, data is coming in other formats. One other new player, Jarek Bernard Converse, is a cornerback number 35 from LSU with April 29th, 2000 as their birthday. Notice if we run this and the date format does not match, we'll see a non-numeric character was found where a numeric was expected. And it's indicating there's a problem with that date. Let's say the dates are all stored in this format, which is what they are stored in on the NFL website. So they're stored in this format. And what we could do is we can give it the value, and then we give it the mask for that. So the month is going to be written out, 2 digits for the day, 4 digits for the year. So effectively, think of it this way. It's like this function is converting that value over to from that format to a date format for us. And again, if we're trying to automate it, this is extremely valuable. And you'll see that's successful. And now if we select everything from the roster copy, we see that it did convert Jarek over to the correct date format. When we talk about updates and deletes, we need to be able to update. Let's say I need to change my mailing address or something like that. That's something that needs to be updatable. Now, what I'm starting from is I've created basically a copy of the roster table, and I've run this command. And we're going to take a look at the roster copy table, and I'm going to take a look at some updates. So if we look at the number of positions here, we see that there's some players that are stored as OGs, which is offensive guard, and there's some people that are stored as G for guard. So we would typically choose one or the other, because otherwise we're going to end up with, well, show me all the guards on the roster. Somebody's got to remember to do both of those. There's no reason for 2 values to be there. Let's see who they are. We see there's 3 players on this list. We have Greg Van Roten. He is listed as an OG. The other 2 are listed as guards. So let's fix that. Now I could certainly go in and do one at a time. But if we know that it's possibly a bigger problem than this, we can use an update query. So this is going to be an update query to update this roster copy. And what it's going to do is set the position to G, where the position is currently OG. It's not worried about capitalization. We could certainly deal with that as well. But if we do this, we will see the number of rows that are updated. We see 1 row is updated. And if I run that same query again, we see that Greg Van Roten is now listed as a guard, and that should help sanitize and clean up our data a little bit. Just to show you a more far-reaching example, notice we have multiple people listed as OLBs, outside linebackers. Maybe we don't want to make that distinction, just lump them all together. And it would be very similar. We would say update the roster copy, set position equal to linebacker where it's currently OLB. And instead of seeing one row updated, this can now make 4 changes. We run an original query. Everybody's now a linebacker in this list. Now we do have to be very careful with this, because if I were to run this query without this condition, disaster would strike. We would overwrite everybody in the databases. We'll do that, but not right now. Now, a couple of real-world examples of this. So I taught at Passaic County for 19 years, and we had students from Elmwood Park. And at some point, Passaic County Community College was around, I think it was 1970, they started letting students in the door. There were still students that had not updated their information in so long. Their town was not listed as Elmwood Park. They were listed as, with the previous name of Elmwood Park, East Patterson. Notice EP, Elmwood Park, EP, East Patterson. So the town kept the same initials. And if this sounds somewhat familiar, it's also because there used to be a West Patterson, or WP. That's in Passaic County rather than Bergen. And that is, of course, Woodland Park. What's interesting is you still see little, like this is Best Buy. I placed a pickup order there a couple weeks ago, and I noticed that it still said Best Buy West Patterson in the title on the pickup. So you still see little echoes of this sometimes in the system. You can see the address is correct, but it does say West Patterson there, official Best Buy website. So at some point, I was there in 2005. We had to run an update query. We had to go and look for students who were living in a town listed as West Patterson and update that to be Woodland Park instead. And that was something you could run blankets on a whole list. Now, you did have to be careful. And in that case, I don't have a students table here, but just to make sure if there wasn't a West Patterson somewhere else, I would also make sure that the state is New Jersey for that person. As you can imagine, if this was Springfield instead and they changed their name, there are many Springfields around the country. So, I'm in Clifton. Clifton is not the only Clifton in the country. So we can use a compound criteria as part of this as well. So since we talked about compound criteria, just keep in mind you can also do more than one update at the same time. And if we were to run this query right here, you could see Brian Burns. We could update his first and last name at the same time, and in addition to many other fields if we wanted to. And we can see one row is updated, and we can see that one command did update multiple rows. Now, if we take a look at the roster for the Giants here, so D. Williams is no longer with the team. Maybe there's a need to delete this player. Now, typically you have to be very careful with deleting like customers. There are legal restrictions. There are rules if you're in financial, student records, advertising to children, a number of rules you have to comply by. So you may not be able to delete somebody, but you may theoretically be able to mark them as inactive, or you could archive them to another table. For the moment, since we want to see the delete command in action, it would be as simple as this. Notice I'm using player ID, which is a unique identifier, which is important because, again, if you just said delete from roster copy, that could absolutely delete everything in the system. So let's give that a shot, and very similarly, we see one row deleted, and if we give this a run, player 030, D. Williams, is now gone. So let's take a look at a breaking update, one that's going to break something. It's an official term, just it's going to blow stuff up. Update roster copy, set position equal linebacker. I have forgotten a where clause. Oops, all linebackers. And if we did that, you could see 79 rows updated. And if you were expecting like 5 rows and you see that 79, that's when that panic sets in a little bit. You say, oh my gosh, I definitely ruined something. And I did. Brian Burnside here is a linebacker, but Russell Wilson absolutely is not, and I don't think he'd be interested in playing linebacker. Now, there might be a way in another database system to do something called a rollback and a transaction. The Oracle Apex site is not really set up to handle those, but just recognize that there may be ways to recover this, but it isn't as simple as just restoring a file from like a backup. It's a very complex process to do that. So let's take a look at a merge. Merge is going to be a way for us to bring data in and kind of effectively it's an if statement. So let's say we have this roster copy. Let's assume we get new data from the league office. Maybe a player has changed their name. Maybe they've changed their uniform number. Maybe they've corrected a date of birth. You might think the name change is uncommon, but there have been a number of folks that have done that. For example, there was a wide receiver who changed his name legally to Ocho Cinco. So Chad Ocho Cinco from Chad Johnson. So let's say we have this new data. So I'm going to assume that we have our roster copy and that we're getting new data, and that's going to be in our roster table. And what we're going to want is we're going to want that to bring in all of the information. And if there's a matching record in roster, overwrite the values here. So what that means is if we do it just with that, we would be able to go in and fix all the positions and names and so on. What about poor D. Williams? He would not be restored if we just did an update. So we need to do both update and inserts together. So I'm going to start by saying merge into roster copy. And I'm going to give it just an alias just to make it a little shorter. But I'm going to use cur1 and new1. But this way, maybe it helps us track it a little better, which one is the current and which one is new. And what we're going to say is we're going to match on those two records being equal. So in other words, the player IDs are equal. Now we're going to be able to give it a couple of conditions here. When the record is matched, then set the current table, roster copy, equal to the new values for the first name, the last name, and the position fields. We could do it for all of them. I just don't want to overdo it because we didn't change the other fields. But to do it right, we probably would do all of them. And notice we'll have update here. And when it's not matched, then we're going to say insert. And we'll list out each of the fields from the current table. So we're going to insert into that current table. We put in each of these values. It will go in. It will perform any updates. So it should match about 75 players and update their position, first and last name. And when it's not matched, it will do that insert. And that's going to be the clause that brings back D. Williams. We see 78 rows updated. Now, what I would expect is Brian Burns' name should be correct. We should not have a bunch of linebackers, and D. Williams should reappear. And as we would expect, there's Brian Burns at the outside linebacker because that change was also undone. We see people at other positions. Once again, D. Williams has returned to the building. Now, the only thing this doesn't fix is the two players who we inserted manually who were not in that original roster, Jarek Bernard Converse and Ray McLeod. Their information, since it was not in the table, those records were not changed. But here's the code. And again, in a real world situation, maybe we need to take the data from two tables and kind of combine them. And of course, they would call that a merge. And if you've ever come out of a toll booth on the parkway, you know what a merge is, where they're taking 4 lanes and shoving them into one. So that's effectively what's happening here. We're combining multiple values into one data source using this merge command. To close out section 12.3, let's take a look at default values. Now, this will be discussed in the next couple of sections, but what I'm going to do is I'm going to alter the roster copy, and I'm going to set the default value for the college field to none. Now, Oracle does this a little differently than some other database tools, some other DBMSs. Most of them use alter column. But you'll see this will allow you to change the design of a table. And what this is going to do is this is going to say if you don't give a value for college, instead of null, we'll give it a default value of none. Or, you could do unknown, whatever you want. So here's another player, This is Corey Black, number 38. He's cornerback, born June 22nd, 2002. And let's say we didn't have Corey's college available, or he didn't go to college. I mean, that does happen. Sometimes you get players that come in internationally, maybe didn't go to college. So this statement, if you notice, is skipping. After position, we go right to date of birth, so we skip college. This is okay because we have none as a default value, although it's nullable, so we could get away with it anyway. But the main difference here is going to be once the insert is done, we see that despite me not typing in a college, it does show up with a default value of none. For example, let's take a website. If you're catering to American customers and you've got a drop down for country, a lot of times that's going to default to USA as the default country. You can certainly go and pick something from the list, but they will give you a default value to save you from having to type that in. And the reason this works is that table design has been changed to allow this. Now, you can put a lot more constraints on this, and it can be very helpful, but it does add a little bit of work and frustration to the user's end. But is it better for your users to be frustrated or put bad data in your system? I think I'd rather have them frustrated. So that brings us to the end of this, and I will see you in a future video. Take care.